Hi everybody, today we are going to learn about potential divider. Here is some circuit for you. Here is one resistor, here is another resistor, and it is connected in series, and voltage across 6 volts, and the resistor value is 50 ohms, 100 ohms. Now here I want to find voltage across this V1. So what I have to do? Now you see what is the total voltage is supplied, 6 volt. This is the maximum available voltage, 6 volt. And this available voltage will be divided by these two resistors. So it is known as divider, potential divider, the energy divider. The total energy available is 6 volt, 6 joules per coulomb. So 6 joules of energy is being transferred to move per coulomb of charges. That is the meaning of 6 volt. So 6 joules of energy is being transferred, right? So this will be divided by these two resistors. So V1 is the voltage is taken by this 100 ohm. How can we find? So here we use cross multiplication. We have formula also, but it is better if we use cross multiplication. You will get the concept. Now you see 50 ohm is a smaller resistance, and this 100 ohm is the bigger resistance. The big resistance will take more voltage. It needs more voltage, and the remaining voltage will be given to 50 ohm resistor. So here is the calculation. How many resistors are there? 2 resistors. First you add these resistors, 150. This is the total resistance. What is the total voltage? 6 volt total voltage. Now you make a column. Here is a volt and here is the resistance. So total resistance is 150 ohms. Will be taking 6 volts. Now I want to find for the 100 ohm. Here is X. Now you cross multiply. 150 multiplied by X is equal to 6 multiplied by 100. So X will be 6 multiplied by 100 divided by 150. So which means 600 divided by 150 will be 4 volt. So here come back. This resistor will take 4 volt. The remaining 6 minus 4, 2 volt. Now you see like this. This is how we have to find. Okay. Now what if one resistor is fixed, another resistor is variant? Here is 0, here is 6 volts, and this one you can take as a variable resistor, that is light dependent resistor. This is the fixed resistor. So how much was the fixed resistor before? 100 ohm. Now this is, initially it was 50 ohm fixed resistor. Now we replace this with the LDR as a variable resistor. What is LDR? Light dependent resistor. It depends light. In the darker room, in the dark room, the LDR acts as a high resistance, higher resistance. And in the brighter room, the resistance, as the intensity of light increases, resistance decreases. So it becomes lower. The resistance becomes lower. Okay. Now here, when light falls on it at one intensity, it becomes 25 ohms. So what is the voltage across the fixed resistor? V1 you have to find. The same story. How will we find? First you have to add the total resistance 125 ohms. Total available voltage 6 volt. Cross multiplication volts and ohms. The total ohms 125 and voltage is 6. And then I want to find for 100 ohms x. Cross multiply. 125x is equal to 600. So x is equal to 600 divided by 125. So you can find the answer. So how much it would be? 1 second. So it is 4.8 volts, like that. Okay. And next concept, here is a thermistor, a fixed resistor is connected. Here is 0 and 6 volts. Okay, here is a 5000 ohms, and here is 2000 ohm to 1000 ohm. Why it is 2000 ohm to 1000? It's a higher resistance. Higher resistance. This is lower resistance, right? So here this device name is called thermistor. Thermistor at the room temperature. At the room temperature, it acts as a higher resistance. Higher resistance. And temperature increases if there is any fire. Temperature increases. So what happens? Resistance decreases. So it becomes lower in resistance. So this is high resistance, so which means that temperature is less, right? So here is a room temperature. This is more than room temperature. More than room temperature, so resistance decreases. So here I have connected a voltmeter. I want to find the voltmeter across the fixed resistor during room temperature and more than room temperature. How does it affect? Do you think will it take the same voltage before and after? No, of course not. Because the total available voltage is 6 volt, and here the 5000 and 2000 will be dividing the total voltage, right? So first we have to do with 5000 and 2000. First you add both. 7000 ohms. What is the available voltage? 6 volts. Cross multiplication. Total voltage is 7000. Resistance 7000 ohms and voltage 6. And I want to find for 5000 x. Cross multiply. So 7000 x is equal 6500. X is equal to 6 times 5000 divided by 7000. Answer is here 4.3 volts. Okay. So now at the room temperature, the voltmeter 1 shows 4.3 volts. Okay. Now what happens if the temperature increases in the thermistor? How does it affect the voltmeter reading across 5000? Alright. Okay. Again we do the same. 5000 plus 1000 now. It is now 6000 ohm. Because as the temperature increases more than room temperature, the resistance decreases, right? So here is the fixed resistor. This value will not change the same. Here 1000, so it is 6000 ohm, right? Next, what is the available voltage? 6 volt. Again, you do the cross multiplication. Available voltage, total resistance. I want to find voltage across 5000 ohm. Cross multiply. So 6000 x is equal to 6000, 6 times 5000. So x is equal, so the answer is here 5 volts. So 5 volts. What happens now, as the temperature changes, the voltmeter reading changes from 4.3 volt to 5 volts. So 4.3 volts to 5 volts, the voltage increases from 4.3 volts to 5 volts. This will be the answer. Okay. Thank you very much for watching.